Night, evening, 8 p.m.
The session is 6 to 8.
So for
Tomorrow.
me, okay, because I have from 2 to 4.
Okay. What about other?
Sir, in my humble opinion, sir, you're recording the video, na, sir. If in case anybody needs that, then they can see the recorded video also, sir. Because
Yeah, that's
yeah, if we keep on certain kin, then we will never be able to do because something will clash because of the large number of students, sir. So
correct.
so sir, we can once you record it, sir, we then another can view the recorded session. In my humble opinion.
Yeah, yeah, that's okay. That's great. Okay, so first of all, then let's start the session and we'll see if you will be having any doubt and all. We can discuss it later also. So basically, this will be the formula sheet for your interim exam. So let me show you for a minute. Okay, so like you will get every distribution with PMF, CDF, their expectations and variances. Okay, for discrete distributions and then for continuous also. There will be Markov inequality, Chebyshev inequality, then weak law of large number, then how to use this CLT and this bias formula, method of moment, so this is the sample moment, and you what you have to do. This is your population moment, and basically we will discuss what is the procedure, and there is something called likelihood, right? So how to find the likelihood? It's a product of all, product of basically probabilities, and then how to find this ML, so maximum likelihood, and then there will be procedures for Bayesian estimation, and then see, for normal we have given the posterior mean and all, but for others distribution it will not be given because that is very easy. I mean, suppose you want to find the posterior mean for gamma distribution, then it's a alpha by beta, right? If gamma distribution has two parameters, let's say alpha and beta, then your posterior mean will be alpha by beta. So something like, suppose posterior distribution you got beta distribution with with these two parameters, then what will the mean? Posterior mean will be alpha divided by alpha plus beta. That is something we will see.
Sir,
And
where is the alpha distribution? There is something called alpha distribution also, huh?
no, no, not
Apart from
alpha.
gamma.
No, not any alpha distribution. It's uniform, exponential, normal, gamma, and beta. That's all.
Oh, okay.
Yeah, there is. So every I mean all the required things will be given to us. No need to worry about this. Okay. Then you can see these kind of all test and all. I mean, in which scenario you can use which test and everything. Okay. Basically, if you write tail, then what will be the rejection region? What will be your test statistics, right? So you can see if sigma square is known, you will use G test, right? This is something you have seen, right, in week 11, correct? If you want to test for mean and your population value is unknown to us, you will go for the T test, not
Sir,
for G test.
sorry to interrupt you, sir.
Hmm.
Actually, whatever the sheet you are showing, and that I have another sheet, sir, where all these formula are not there. Only first two pages are there, sir. From where I can get this sheet, sir?
No, no, this will be given to you in your interim exam. See, if you are saying only these two, right, till here only. I
No,
think you are saying till CLT.
yeah. Page two, sir.
Yeah, yeah.
Okay.
So let
I
me 1 second. Let me explain. So formula is provided as per the level of the exam. If it's quiz one, then there will be formula only till here, Chebyshev inequality. If it's quiz two, you will get the formula sheet till CLT. If it's NTERM, then you will get all these formula sheet. Okay. So it will be attached with along with your question paper. Okay.
can you share this sheet, sir, if it's available to you, sir, so
Yeah,
that
I
we
will share at the end of the session. Okay.
fine,
Uh,
Uh,
fine, sir.
Maybe
so.
one question outside of this topic. See, is
Hmm,
it like a end time exam is from 1 to 12 or
correct. 1 to 12.
okay, okay, sure.
Yeah, and I have posted the week wise weightage on Discord, so you can cross check from there, right? Accordingly, you can prepare for your exam. So you can see all this test has been given, right? What is the rejection region and all. So actually, if you are able to read or if you are able to understand what all these things, so it's something you can say hint from my side. You will get some marks for from week 12. If you are able to understand this scenario, means when sigma square is known, then which test you can use, if sigma square is unknown, which test you will use, I mean something like that. So you should be able to understand this kind of formula. Okay, so let me start the week 9 and 10 session. So I will quickly discuss the concept first of all, and then I have collection of the questions which has been asked in the some previous terms actually. So along with their marks, what was the weightage? So this 3 marks is was out of 40. So suppose you have corrected it, then 3 into 2.5. So out of 100, you will get, I mean 3 into 2.5, how much? It will be basically 7.5. So for a very basic question, you will get some good marks. So the thing is, I will quickly go through the concept and then we will try to see the questions. So I have collected lots of questions. So I will solve the questions as well and keep a pen and paper ready with you so that I will give you some sort of idea. I mean, once you will get some idea, then we'll try to solve the questions along with me. Will that be all right for everyone?
Sure, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay, great. All right then. Okay, so in week 9, so we will start basically from the estimator. Okay. So it's called basically parameter estimation. So in what is a parameter estimation? So as we have discussed in week 9 open session. So thing is, suppose you have the scenario, but you don't know the value of the parameter. I mean, value of the population parameter. Let me say. So I'm saying I have x1, x2. I'm saying I have this and IID random variables. So these are IID random variable from some. Let's say I'm saying with a normal distribution, with some mean mu, but let's say some variance. Let's say 16. Thing is, I don't know this mu. Then how I can calculate the mean? Okay, how I can calculate this mu, how I can find this value of mu? Is there any mechanism I can find the estimator for mu based on this sample data? Okay, so if you have large population, you are not able to calculate this. So the, uh, I mean, with the help of sample data, I'm going to estimate my population parameter, which is mu, which can be sigma square also, something like that. Okay, so parameter estimation is nothing but is the process of basically, like you are going to use your sample data to estimate the unknown parameter for a population. Those parameters can be mean, variance, or probability of success, anything, right? Am I clear?
Yes, sir.
Okay, so basically, what is the estimator? If you have seen from your lecture, so estimator is nothing but it's a function of the samples. Okay, so what do I mean by function of samples? Suppose for mu, you have seen sometimes x bar is the estimator, right? So what is x bar? Normally 1 upon n summation of xi. What is this xi's? Xi's are samples, right? So this x bar is what? Function of samples.
Yes, sir.
Right? So based on different values of xi, your x bar can change.
Yes, sir.
Correct? So basically your estimator is always a random variable, while your parameter is a constant value. Yes or no?
Yes,
Yes, sir.
Okay. Yeah. So this is just a definition of estimates. So if you want to generalize it, so you can simply write estimator as a, let's say theta hat. It can be mu hat. It can be p hat. Anything, just a notation. Hat means you have estimated, and this will be function of your samples. Okay, so this is just something you can see here. This is the 1 second. So here you can see for estimator of mu, there are 3 different estimators. So you can see all these 3 are function of samples or not. You can see x1, x2, x5 are ID samples, and you can see this estimator is also function of sample. This estimator is also function of sample. This estimator is also function of sample. Correct?
Yes, sir.
Yes,
Right.
sir.
Oh, so now there is something called estimation error. Okay. So estimation error is nothing but basically the something which you have estimated and difference with the true value, right? So for example, you know something true value. Let's say mu is going to be, let's say 68 kilogram. For example, I'm talking with respect to weight, and with the help of samples you got, let's say, estimator, with the help of estimator you got weight as a, let's say, 67.5. Then what is the error? How much error is there? This is the difference between these two, right?
0.5.
Yeah. So basically it's a error is nothing but it's the difference between uh, estimated and the true parameter. Okay. And one more thing, this error. Okay, tell me, this is the random variable or not? This error,
Random.
Variable.
random variable, because this is random variable and this is constant, right?
Constant.
So suppose x is the random variable and minus a is a constant, so x minus a is again a random variable, right?
Yes, sir.
Okay. Okay. One more question. Suppose you don't know this theta, then how will you find this error? I mean, what's the role of this error? Any idea?
No, what is the question, sir? Again?
My question is, suppose you don't know, I mean, in general, we don't know the true value of this theta, right? Then what is the use of this error? I mean, where you can use this concept of error? Are you getting my question?
For any acceptable values or range?
Correct. Basically, you can use in confidence interval. That is something we are not going to study, but let me give you idea. So basically, suppose I'm saying this is called, what is the probability that, suppose I'm saying probability that this is less than 0.03. Suppose I'm saying this is 0.95. Okay, I will explain you the idea behind it. So what it will be? It will be minus 0.03. Yes or no? And theta hat minus theta less than 0.03 will be 0.95. Yes or no? What
Yes.
else you can write? Theta hat minus 0.03 less than theta hat minus 0.03, not minus, plus,
Yes.
equal to
Yeah.
0.95, right? So the interpretation what you can make, the true value, I mean, value of the true parameter, I mean original parameter, will lies between this value and this value. For this you are 95% you sure, or you can say you are 95% confident the value of the true parameter is going to be lie between this value and this value. Are you getting my point,
So
right?
that means if the error is least, then the value
Correct.
of theta hash will be closer to the value of theta.
Closer to value. That's why we are saying estimator, you maybe you have seen this theta hat is close to theta in probability, this theta is close to theta in distribution. In distribution we are not going to study in statistics course. That is something deep, in more depth in stats world. But we are saying in weak law of large number, we are saying, right, x bar is the close to mu in probability. Yes or no? Right, you have seen, right? So basically we are trying to find the next concept comes, the error should be minimum. Okay, whatever the error is there, suppose error you are defining as a theta hat minus theta, then error should be minimum or not, right?
Yes.
Basically, okay, what should if I'm writing the absolute value of error is less than some small value delta, what should be this probability? This probability should be large or small? Just think a
Small.
bit.
Small, small.
Just think a bit. I'm saying probability of absolute value of error is less than some quantities, very less, very small quantity.
So small, sir.
No, it should be
Okay.
high. It should be
It should
high.
be high,
Should
right?
be
High.
high because we want a smaller error.
Correct.
Correct.
So if I'm saying this is 0.99, that means I'm saying the this error, I mean theta at minus theta, is less than, for this I have 99% probability, right? Probability of 99, basically. Are you getting my point?
Yes.
So so what is the key thing here? We have to observe the error should be small. Here it should be least, right? It should be small. I mean, the you can focus on this statement. You are saying the error is greater than some quantity. Then for this whole part, my probability should be less. Correct?
Yes.
So the next thing is it's called bias. Okay, so how you can calculate the bias? So bias of is just defined as is nothing but expected value of your error. Okay, so I'm quickly go through that. Will not go to in any derivation today. So I will basically revise the concept as per the exam point of view. Okay, will that be all right for everyone? So this is something I can write expectation of theta at minus theta or not. So this is the formula for bias. Okay. So if I'm saying bias is 0, that means what else I can say? Expected of theta hat minus theta is 0. That means expectation of theta hat is equal to theta. Yes or no? So for this true parameter theta, my estimate, if expectation of the theta hat is equal to theta, then I will say this estimator my theta hat is an unbiased estimator. Is it clear?
Sir, theta is the error, no?
No, theta is not error. Theta is the true value of your parameter. Okay, is the original
And
value. The
theta,
something. So
Theta
if
hash minus theta is error.
yeah, theta hat minus theta is the error. This is the error.
okay, sir.
Okay, basically you want expectation of the error should be 0. Okay, so if I'm writing expectation of x bar equal to mu, then what should what I can say? I can say x bar is an unbiased estimator of theta. Will you agree with me?
Yes.
Yes, sir.
Okay. The next thing is called variance of error. So variance of error is variance of theta hat minus theta. What is this? Theta is a constant. So can I write variance of theta as a variance of theta hat? Basically, what I'm saying, variance of x plus
Correct.
a is equal to
Correct.
variance of x or not?
Yes. Correct.
Correct? Right? And there is something called risk of the estimator. Okay. So risk of theta hat is nothing but, okay, what is the formula? Because this is going to be important for your exam. So I'm emphasizing on this. This is important for exam. So what is
E
the
of
risk?
E of x square plus E of ex whole square.
No, you are explaining the formula of variance.
No, I'm saying
Square
E.
of bias minus
This one.
variance.
Okay, let me tell you. So this is the formula for risk. Expectation of theta at minus theta whole square. Okay. If you will expand this, then this will something you will get at the end. Expectation of, basically this is something expectation of x square, right? Just treat this as a single quantity. Okay. What is the variance of x? Expectation of x square minus expectation of x whole square. Yes or no? If
Yes,
I
sir.
need expectation of x square, what I can write variance of x plus expectation of x whole square. Yes or no?
Yes.
And this is something you can treat as a x. Then what else you can write for this term?
Variance of x plus
You can write
expectation.
variance of theta hat minus theta plus expectation of theta hat minus theta whole square or not? Would you agree with me?
Yes, sir.
So this is something. Yeah,
Sir,
yeah, yeah,
here,
yeah.
can you just explain this part? I'm not able to.
One second, one second.
Yeah.
Now tell me, if is this formula clear? Variance of x is what? Expectation of x square minus expectation x whole square.
Correct.
Correct? If I need expectation of x square, then what I can write? Variance of x plus expectation of x
Correct.
whole square. Now
Correct.
just treat here x as a theta hat minus theta. Then what is this? Expectation of x square only.
Oh, okay,
So
okay.
this is variance of x plus expectation of x whole square, right?
So of x plus E of x whole square. Ah, yeah, yeah.
Correct? Now what is this? This is bias square plus variance. Clear? And this is the bias only, right? Bias is what? Expectation of error, right?
Yes, sir.
Are you getting?
Yes, sir.
Bias is what? Expectation of error. So this is expectation of theta hat minus theta whole square. So this is called bias variance trade-off. So risk of theta hat comma theta is equal to bias of, I mean, square of the bias plus variance of that estimator. So this formula is very, very, very important for your this NTEM exam. Okay. So this is something I'm emphasizing on this. So just make this formula keep in your mind. Okay. Now let's do this question. Okay. Everyone has pen and paper right now.
Yes, sir.
Yes, sir.
Okay, so let's try to understand the question. So what question is saying, suppose x1, x2, x5 are IID samples from a distribution X with an unknown mean. We don't know the mean mu with variance sigma square. And there are three different estimators for this mean mu. Okay, we have to check as per the options which one is the basically whether all the estimators are unbiased or not. Okay, to check the unbiasedness, what we have to do? We have seen bias should be 0. Correct?
Yes.
Bias should be 0. That means what? Expectation of theta hat minus theta should be 0. This means expectation of theta hat should be equal to theta. Then I will say this is unbiased.
Yes, sir.
Right?
Yes, sir.
That means here you have to check whether expectation of mu1 hat is equal to mu, expectation of mu2 hat equal to mu, and expectation of mu3 hat equal to mu or not. If all these three will be correct, accordingly you have to choose the option. Is my question is clear to all of you?
Yes, sir.
Yes.
Right? So should I do? Let me
Yes.
do this one. Okay. Let's try to do. So option A and C is correct. Let's see how. So what is this mu1 hat? So basically to check biasness, I will say expectation of mu1 hat, that is expectation of x1 plus x2 plus so on x5 divided by 5 is equal to, can I write 1 by 5 and in the numerator expectation of each individual exercise?
Yes, sir.
Yes, sir.
Right? And what is the expectation of each exercise from the question? These are IID sample with mean mu.
Yeah.
So what I can write? Mu plus mu plus mu plus mu plus mu divided by 5. So this is 5 mu divided by
Fine.
5. So 5 will get cancelled. What I got?
Yeah.
Mu, right?
Yeah.
So this is something I got. Expectation of mu1 hat is equal to
Yeah.
mu. That means this is unbiased estimator.
Yes.
Correct?
Yeah.
And what about expectation of mu2 hat? So expectation of mu2 hat, if you see, if you apply the expectation formula here, what you will get? Half and expectation of x1 plus expectation of x2, right? So this is for this only, plus expectation of x3. Are you getting? Or is it
Yes, sir.
messed up?
Yes.
Is it
Not
able
clear,
to
sir. Not clear.
clear, right? So what is this part? This will be mu plus mu, right? Basically 2 mu
Yes, sir.
plus expectation of x3 is again mu. 2 will get cancelled out. You got 2 mu, correct? So this is
Yes.
something here you got expectation of mu2 hat is nothing but 2 mu. Is this equal? This is not equal to mu. That means this is not unbiased estimator, right?
Yes, sir.
Yes, sir.
Yes, sir.
Correct.
Yes.
So that's why option B is not correct. Let's see for mu3. If you see mu3, then expectation of mu3 hat is what? It will be 2 times of expectation of x1 plus expectation of x2 divided by 3, right?
Right.
So this will be 2 mu plus mu divided by 3, which is nothing but 3 mu divided by 3, which is mu. So expectation of mu3 hat is equal to mu. That means this is unbiased estimator. Is it clear? So now
Yes.
you can see you will get some out of 100. It will be you will get 7.5 marks if you are attempting at the correct. You can see we have to just apply very basic formula to check the unbiasedness. Expectation of theta hat should be equal to theta. Is this clear to all of you?
Yes, sir.
Yes, sir.
Now, if you this is clear, the next question is based on the same concept. Okay. So suppose x1, x2, x5 are IID samples from a distribution X with an unknown mean mu and variance sigma squared. There is one estimator mu hat is 2x1 plus x3 plus k times of x5 divided by 10. This is an estimator of mu. So you have to find the value of k for which bias is 0. Then what will you do basically? Tell me.
Sir, this whole should be equal to mu.
No, we need to find the expected value of mu cap.
Correct.
So expected value of mu cap equal to.
So just keep in this mind, right? Bias of mu hat equal to of bias of estimator is
Should
nothing
be
but
0.
K should be
expectation of
780.
mu. Correct. So this should be 0. So this means expectation of mu hat minus mu 0, right? So basically, I will say expectation of mu hat equal to mu. So if you see in the formula file, right? So let me show you. You can see this is given to you, right? So I'm saying bias is 0, right? That means this expectation of theta hat minus theta is 0. That means if my expectation of theta hat is equal to theta, I will say my estimator is unbiased. All right. So here you have to check expectation of mu hat. I mean, basically this will be equal to mu, right? Because it's saying it is bias is 0. I have to find the value of k for that particular scenario. So this will be expectation of what is the mu hat? 2x1 plus x3 plus k times of x5 divided by 10 equal to mu. Are you getting my point, right? This is something we have to use. Yes, no?
Yes, sir.
So this will be 2 times of expectation of x1 plus expectation of x3 plus k times of expectation of x5 or not? Equal to mu.
Yes.
So 1
Yes.
upon 10, if you see this is 2 mu because for each xi is expectation of x is mu. This will be mu plus k times of mu equal to mu. So this is 3 mu plus k mu equal to 10 times of mu because 10 you can multiply with on right hand side. So if you see what you got, k mu equal to 10 mu minus 3 mu, which is 7 mu. Mu will get cancelled out. So value of k is
7.
so you can see which is the answer. So you can see the concept is the same, just minor you can see manipulation and I mean question is I think okay. What do you feel about level of the question?
Easy one.
It's easy, right?
Easy.
Yes, sir.
Okay. So this is something you can find this kind of question. Okay. One more thing. Tell me. Okay. In the first question, if I will ask what is the risk of mu hat, mu 1 hat, then what you will do? You will do bias square
0.
plus variance of mu 1 hat, right? And bias we know this is 0. And what is the variance? Whatever the variance will be there, right? Basically, variance will be sigma square, sigma square, sigma square, sigma square, sigma square, 5 sigma square divided by 25, right?
So sigma square by 5.
Sigma square by 5. So risk will be sigma square by 5. So you can see if your estimator is unbiased, then your variance is same as risk. Okay. Now, so I would like to, I mean, I
What is
want
the
you.
risk, sir?
Sir,
Here?
Yes.
Can you say the last sentence again?
What?
exactly. So then this new equations or variance, whatever you have said, can you repeat once again, sir? Risk, sir. You just tell me once
Yeah.
again.
So if bias is 0, then your risk is equal to variance.
Okay.
Okay.
Risk means what, sir? Risk of the parameter means?
See, risk is something just it's the addition of bias square. Okay, if you see risk is nothing but I think we have discussed already. So risk is nothing but if you see it, so risk is nothing but square of the error. This is something formula of risk. Okay,
Expected
and
square.
yeah, it's expectation of error is square. Okay, if you expand this, you will get the bias square plus variance of that estimate. So I would I want to try to all of you this question by using the same concept. Okay. So would you like to do or should I do?
Yes, sir. Yes.
Yeah, please try it. It will give you some idea. Okay.
One thing, sir, I like to share, discuss with you, sir. In the sir, just question whatever you discussed. Come again, sir, scroll up, sir, little bit. What variance you have risk? Yeah, exactly, sir, exactly. Sir, here, sir, you have divided by 5 because the number of samples are 5, isn't it,
No,
sir?
no. So if you see variance of mu 1 hat, right? So variance of mu 1 hat will be variance of this summation xi divided by 5, right? 1 upon 5, if you take outside, it will be 1 upon 25. Yes or no? Because variance of any constant into random variable a square variance of x. Okay. And in the numerator, we know all the random variables are IID, so it will be variance of x1 plus variance of x2 plus variance of x5. So all these are sigma square, sigma square, sigma square. So it will be 5 times of sigma square, and 5 times of sigma square divided by 25, it will be sigma square by 5. Okay?
Not able, sir. Just a little bit once again, sir.
I think you haven't attended the open session, right?
No open session, but I,
Yeah.
sir.
Okay, let me say. See,
Yeah.
it was x. Let me tell you the for this was the, we have to calculate the variance, right? You know variance of a times x is what? A square variance of x, correct?
Yes.
And what is a here? 1 upon 5. So it will be 1 upon 25.
Okay.
It will be variance of x1 plus so on variance of x5. So I'm able to write, because all our random variables are IID, right? That's why I can write as a sum of individual variances of individual random variables. So it will be 1.25. And what is the variance of each x? It's given as sigma square plus sigma square plus so on sigma square. How many times? 5
5
times.
times.
So 5 times of sigma square, this is 25. So it will be sigma square by 5. Okay.
Got it, sir. Got it.
So yeah, please try this question. You have some 2 to 3 minutes, I think.
So 3.
Let's wait for others. Okay. Everyone is trying, right? It shouldn't be like I'm waiting for your
Trying,
answers.
sir. We are trying, sir.
Yeah, thank you. Question is that much difficult, or you are lacking somewhere?
K is equal to 3, sir. It's not difficult, but starting we took time, sir, to understand.
Okay. Okay. So what is you got? I mean, what else you got? I mean, what do you understand by this question?
Yeah. So basically, we need to find the expected value of mu2 cap, and then we get the expected value of mu1 cap, and we need to substitute this value 2 mu plus 3.
Yeah, basically that is something. If you focus on this statement, so mu2 will be an unbiased estimator of mu. This means what?
Expected value of mu2 should be equal to mu.
Mu2 hat should be equal to mu, right?
Yeah.
Now we have to just substitute the value. That's all. Basically,
Yeah,
we have to so expectation of. Okay, let me do it. Okay, let's catch up. So what is the mu2 hat? It's a mu1 hat minus k divided by k minus 1, which
Yeah.
is mu. All right. So this is constant. We know expectation of a times x is what? A times of expectation of x. Correct? Now, so 1 upon k minus 1 I can take outside. Then in the numerator part, it will be expectation of mu1 hat minus k, which is equal to mu. So far, so good. So it will be expectation of mu1 hat minus k equal to mu times of k minus 1. Yes? No?
Yes, sir.
Yes, sir. And if you see the left hand side, I can write expectation of mu1 hat minus k. And this will be mu k minus k.
Minus k
No,
cancel.
minus mu. Sorry, not minus k. Minus mu. Right? You have to just multiply this.
Correct.
Now, what is the expectation of mu1 hat? You know, this is given to
2
us
mu
mu2 plus 2 mu2 plus 3. So 2 mu2 plus 3 minus k equal to mu k minus mu, right? Basically, we have to just do the basically adjusting part. So it will be, we can do mu 2 mu plus 3, right? And then I can do mu k plus k. Any doubt till now?
No, sir.
So this will be 3 mu plus 3. This will be, here I can take k as a common. It will be mu plus 1. And left hand side I can take mu 3 as a common. It will be mu plus 1 equal to k times of mu plus 1.
Yeah. So k equal to 3.
This will be, this and k will be 3. All right. So this is something calculation part. One is smart thing you can think. Basically, you can just simply substitute here 2 mu plus 3 and think about the value of k, which can give you the value as a mu, expectation of mu2 as a mu. Is this clear, right?
Yes, sir. Clear.
Sir. Okay, then let's do this question. Okay. So this question says you have 3 IID samples from distribution X. We don't know distribution, and a known mean mu and variance sigma square. So there are two estimators, mu1 hat, which is defined as x1 plus x2 minus x3, and mu2 as 2x1 minus 4x2 plus 3x. You have to check which option is true. Actually, A and C is true. Let's cross verify. So if you see, we are talking about bias. Bias should be 0. So bias, as we know, bias is 0. This means what? We have to check expectation of mu1 hat should be equal to mu. Correct? So here we have to check expectation of mu1 hat should be equal to mu. Now expectation, what is the mu1 hat? You can see x1 plus x2 minus x3. What is this? This will be expectation of x1 plus expectation of x2 minus expectation of, what is the expectation of each exercise?
Mu.
So it will be mu plus mu minus mu. This will get cancelled out. You can see this is mu. So that means bias is 0.
Yes, sir.
Or else you can say mu1 hat is the unbiased estimator of mu. Okay. Let's cross verify option B. So for option B, expectation of mu2 hat we have to check. So what is the mu2 hat? Mu2 hat is 2x1 minus 4x2 plus 3x3. Yes or no? So if you take expectation inside the bracket, it will be 2 times of expectation of x1 minus 4 times of expectation of x2 plus 3 times of expectation of x3. So what else you got? 2 mu minus 4 mu plus 3 mu. So this will be 2 mu, 2 and 3. Basically 2 minus 4 minus 2 and mu.
This one mu only.
Mu, right? So this is unbiased, but option B says its bias is non-zero. That means this is incorrect, right?
Yes, sir.
Now we have to check the variance part. So basically, if you see what is the variance of mu1 hat. So what is the mu1? It's a x1 plus x2 minus x3, right? So x1 plus x2 minus x3. Since all are IID, what else I can write? I can write variance of x1 plus variance of x2 plus variance of x3 or not? Because this will be minus 1 square into variance of x3, right?
Yes, sir.
Everyone is getting this part. sometimes what people make mistake, they simply write variance of x1 plus variance of x2 minus variance of x3. So this is incorrect. Okay, please make sure this shouldn't be. So what is the variance of each xi? It's a sigma square, and sigma square, which is 3 sigma square.
Yes, sir.
Now what is the variance of mu2 hat? So variance, what is the mu2 hat? If you see, mu2 hat is nothing but this part, 2x1 minus 4x2 plus 3x3. So this is 2x1 minus 4x2 plus 3x3. So since all xi's are IID, what else I can write? Variance of 2x1 plus, basically it will be minus 1 square variance of 4x2 plus variance of 3x3 or not. And we
Yes, sir.
know variance of a times x is a square variance of x. So this will be 2 square, that is 4 into variance of x, plus 4 will be outside. So this will be 16 into variance of x2 plus 9 times variance of x3. So it will be 4 sigma square, because variance of each xi is sigma square. So it will be uh, 29 sigma square, right? So you can see which variance is less. Variance of mu1 hat is less than variance of mu2 hat. Okay, because variance of mu1 hat is what? Only 3 sigma square, right? And variance of mu2 hat is 29 times of sigma square. Okay,
Yeah.
so you can see, so option C is correct, not option D. Is this clear?
Just sir, why how you remove the minus sign, sir? I just want to know just that, sir.
Sorry.
In the sir formula, you written that minus was there, but it was make plus by minus one square, sir.
Variance of x1 plus x2, right? If xi is independent, I will write variance of x1 plus x2. I can write
Exactly.
when this is independent. If it's not independent, you can't write. If I'm
Okay.
writing variance of x1 plus minus x2, can I write variance of x1 minus x2, x1 plus minus 1 times of x2?
Yes, sir.
Can I write
Because the
variance of x1 plus variance of minus 1 times of x2? This plus this.
hmm.
Okay. Now this is variance of x1, and this minus 1 will be minus 1 square into variance of x2. So this is variance of x1 plus variance of x2. Okay.
Okay, sir. Okay.
Okay, this question is clear to all of you. You can see the questions are very easy, which we are giving in term, right?
Yeah, they're just tricky but easy. Yeah.
Yeah, yeah. So it's this level of questions you can, if you are able to do this. Okay, next is method moment. If you are able to do this kind of question, right? So I'm sure you will score good marks.
Sir, this type of question is expected in term now.
Yeah, yeah.
Okay.
Okay, so next is something we are going to yesterday is called method of moments. Okay, so we will see is there some method to estimate our, I mean, to do the basic procedure of parameter estimation. Okay, so what this method of moment says. Okay, so I will quickly go through it basically. Okay, so in method of moments, what is the case? Suppose I'm saying x1, x2 up to xn. This is some IID x with some unknown parameter. Let's say mu and variance. We don't know, but how you can calculate? So there is something called sample moments. Okay. So what you have to do basically? Okay, in week law of large number, we have seen, right? So we are saying x bar is close to mu, right? Yes or no? So basically, what is the sample moment? Let me go. So just a notation, I'm writing mk of, in general, x1, x2, xn. So this is basically kth moment. It is nothing but 1 upon n, summation of I is equal to 1 to n xi raised power k. Okay, this is kth sample moment. Okay, let's say I'm talking about a particular let's say sampling instance. Okay, particular sampling, you can say. I mean, suppose your random variable is taking values x1, x2, small x1, small x2, small xn. Okay, so what will be the first sample moment? So first sample moment will be m1 equal to 1 upon n. You can say this is kth moment. For kth, power is for k. For first, power will be 1. So it
Okay.
will be summation I is equal to 1 to an xi. Basically sample mean only, right? Yes or
Yes,
no?
sir.
If I'm talking about second sample moment,
Sir, here sampling instance are also IID, no?
yeah, this small x1 is just one value of this your capital X1. Okay.
Okay, okay.
This small second sample moment means I'm talking about 1 upon n summation I
Yeah.
to n xi square.
Yeah. Sir,
Okay.
is it the expectation of x square?
No, this is not expectation of x square. This is sample moment. Expectation of x square is the population moment. Okay. Expectation of x is not same as the, you can't say this is the same as the exact mean. Expectation of x is the long run average. Okay. And we are saying the x bar is close to expectation of x. Okay. I will tell you that one also. So this is for sample moment. Whenever you are talking about the sample moment, what is the called the population moment? So what do I mean by the population movement? The something which you are not dealing with the sample data. Here I'm dealing with the sample data. So population movement means if I have something, let's say distribution x, so expectation of x will give me the first moment. Okay, and expectation of x square, this is something you have seen from MGF, right? The expectation of x square called this is called second moment. Expectation of x cube will be
Third moment.
third moment. Expectation, similarly expectation of x raised power k is what is this will be
Moment.
kth moment. Okay, so and how you can calculate the expectation of x? This is summation of x into p
P.
of x if x is discrete. If x is continuous, you will do integration of this part, right? So this is not the average. If you want to calculate the expectation of x square, then what you will do? Summation of x square, probability of x equal to x in case of discrete. In case of continuous, it will be x square fx dx. Is this clear?
Yes, sir.
Okay.
Yes.
So basically, this is justified by B equal of large number and central limit theorem. Basically, so what we have to do in method of moment, basically, what is the procedure? Okay. So in method of moments, tell me if you have to calculate one unknown quantity, then how many equations you need? I mean, if I have to calculate, let's say x plus 3
Two
equal to 4.
equations.
If I need value of x, how many equations I need? Only one equation is enough.
Yeah.
One,
Yes.
one.
If I have to
One.
calculate, let's say two unknowns, then how many equations I need?
Two.
Two
Two
equations.
equations, right? So similarly, if you have to estimate one parameter, right, then you will equate first sample moment to first population moment. Are you getting? So basically, if I'm saying I have to calculate, let's say one parameter only. Let's say I'm saying I have to one parameter for one parameter only. Let's say for one parameter. Then what I will do? I will equate my sample moment. What is this? This is M1 to distribution moment, which is expectation of. Are you getting? So if I need only one parameter, if you have been given two parameters, I mean you have to do the estimation procedure for two parameter, then how many equations you need? Two, right? Basically, you will equate M1 equal to expectation of x and then M2 equal to expectation of x square. So usually in your end-term exam, you will get for only one parameter. Don't worry about two parameter. Let's see how to equate it. So basically, what is the procedure? What is the M1? M1 is nothing but 1 upon n summation of xi, right? This is something you will equate with expectation of x.
Correct.
Okay.
PA. Excellent.
Okay, so let me take one example, then I will move to the question part, which question which you have been given in your quizzes actually. Okay, I will take very simple example, one of the simplest example. So let's say I'm saying I have x1, x2 up to xn. This is IID Bernoulli P. We don't know P. We have to estimate the this parameter P. Now this is only one parameter, right? Then to estimate P, what we have to do? We have to equate the first sample moment to the distribution moment. So basically, this expectation of x, this is expectation for this your distribution, whatever the distribution will be given to you, and this M1 is something you have to calculate from the sample. So this is sample moment, and this is the distribution moment. Are you getting my point? So what is the expectation of x in case of Bernoulli?
NP.
B.
P only. NP in
Correct,
case
correct.
of binomial, right?
Yeah,
And
correct.
what is the
Sorry.
M1? 1 upon n
Summation
summation of,
Xi.
that's all. This is the estimator. So P hat will be 1 upon n summation of xi. So suppose I'm saying x samples are given like this 1 0 0 1 1, then your P hat will be what?
3/5.
3 by 5. So this will be your answer. Is this clear?
Yes, sir.
Okay. Let me do one more, then I will move to the question part. So suppose I'm saying x1, x2, xn. This is IID from exponential with parameter lambda. I have to find the estimator for lambda. Then what I have to do? I will equate first sample moment to the population moment or distribution moment, right? What is the M1? 1 upon n summation of xi's, right? So this is something you can calculate from the sample data. What is the expectation of x
1
in
by
case
lambda.
of 1 by?
Lambda.
Since you have to calculate for lambda, then what it will be? It will be lambda equal to n by summation of xi or not,
Yes, sir.
Yes, sir.
Yes.
right? Suppose you have been given some values, let's say 1 2 3 1 like this. Then what will be lambda at? It will be 5 divided by addition of all these three, which is
8.
8.
8
So
by
this will be value of this lambda. Is this clear?
yes, sir.
Yes, sir.
Clear, sir.
Hmm.
Sir, one sir, very basic understanding. I just want to clear after watching Andrew sir videos.
Mhm.
For example, sir, samples, sir, we can infer that when we have a, for example, population, sir, we have a whole set of data, sir. We suppose we take sample randomly from this, and we want to infer from sample the qualities of the population, right, sir?
Correct. Correct.
Now, exactly. Now, sir, I just want to know in case of IID, exactly, sir, you divide, for example, the sample number by 5.
Hmm.
Basically, in the formula file, sir, one way we say this distribution is uniform, what we getting the expected value? This is for whole population, sir, or what? And now the samples we are dividing by 5, sir, for whatever the number of the sample. This
Correct.
is a little
No, no. Okay, so basically expectation, this expectation part, this is for your distribution. Okay. This is
okay,
called distribution moment, right? So distribution
okay,
moment. So whatever the, suppose I'm saying x1, x2, xn are, let's say I'm saying x1, x2, xn. These are some IID x. We don't know x. So if I'm talking about expectation of x, so this expectation of x will be for this distribution. Okay. And what I'm going to do, since we know by the statistics and all, we are based on the sample, we are going to infer about population, right? So what I
exactly.
will do, I will equate the sample moment to the population moment, right? So you can't equate sample mean for the population variance. No, right?
Okay, okay,
You are dealing with sample mean for sample variance. Sorry, population sample mean for population mean, right?
yeah,
This is something you can do, right? So
yeah,
basically, so for this sample I will do 1 upon n summation of xi, and we know by the weak law of large number and all. See, what is the best, if you know, if you focus on the definition of the expectation is what? It's a long run average, right? So if you do the sum experiment again and again for a large number of times, right, average of those results will be close to expectation.
yeah,
Okay. And by the weak law of large number also, so the very basic thing, the sample statistic, you can say. Statistic, I mean sample mean, sample variance, or some probability. This is close to population, or you can say the original distribution parameter. Okay. So sometimes I will say x bar is close to mu. So if I'm saying expectation of x bar equal to mu, that means this is unbiased meter of mu. Okay. So by weak law of large number, I can say this is, maybe you have seen, is sample variance is close to sigma square, yes or no? That is something we have seen, right? For
yeah,
large n, right? So this means what we are doing, we are equating this sample moment to this population part. Okay, so
Got
that's
it,
what
got it,
we are
got it.
doing here. So 1 upon n summation of xi is for k. We are equating expectation of x. So this is for distribution, and this is for my sample data. Okay.
Got it, got it. So in the formula file, sir, for example, if you open it, sir, in the uniform, sir, in the beginning, sir, in the beginning, sir. Now, sir, if I PMF, sir, PMF distribution, sir, discrete, sir, in just little above, sir. Now, sir, here, sir, what we have given, sir, for example, the variance, this is for distribution. So in the formula, what we give variance x, that is for distribution, sir. And by sir, this what we can infer, sir, that this particular distribution, this large population distribution follow this variance, sir. We can
This is
what
not
we can
follow
say.
this variance. See, if you are saying any random variable is from this uniform A, okay,
Yeah.
with parameter this, then expectation of that will be a plus b by 2, and variance this will be n square minus 1 divided by 2. Okay, so if you see what is this, if you see for Bernoulli, what is the expectation? Mean of this is p, and variance is p into 1 minus p. This p I have used just now to calculate the, you can see, so this p I used, this is the expectation of x, so this, which is p, so this p we have used to find the estimator. Okay, so this is mean expectation of this distribution, variance of this distribution. Similarly for binomial, this is you can see for exponential, right? What is the expectation? This is 1 by lambda. What I did, I equate 1 by lambda to 1 upon n summation of xi just now. So lambda hat will be n upon summation of xi.
Got it, got it. So this concept is clear, but I just want for my general understanding, I just want to know in the formula, sir, for discrete, sir, for uniform distribution, what we can physically interfere, what is the variance x means, sir? How this one particular sample is different from another, what we can see in the physical context or abstract idea, what we can infer, sir?
See, variance tells us you the variability in your data set, right?
Distributions are separate, sir, basically we can say.
See, variance is always tells us you the variability in your data set. Basically, variance is what? If you see the formula, variance is what? Expectation of x minus mu whole square, right? So variance will tell you what is the difference from your mean for, I mean, how far is your random variable from its mean, each value of your random variable, basically. Okay, so you are taking the square and you are taking the expectation. That is something variance of general formula for variance, right? General concept behind the variability. Okay, for different kind of distribution, you will get different form of variance. Okay,
fine, thank you.
Yeah,
thank you.
Okay, so this sample method of moments is okay to all of you. Should we start the question part? Okay.
Yes.
Okay, all right. This is okay. Then let's try to do one question, which is was, I think, in Jan or September 23. I can't recall the exact term. So question is, suppose the time taken by a delivery service to deliver a package in hours follows an exponential distribution with parameter lambda. The timings in hours from a random samples of 6 deliveries are follows. So this is basically, this is small x1, small x2, small x3, small x4, small x5, small x6. Yes or no? Find the method of moment estimate of lambda for the given sample. Okay. So what we have to do, since we have to estimate only one parameter, what I will do, I will equate m1 to expectation of x. Would you agree with me?
Yes, sir.
And what is the m1 basically? 1 upon n summation of xi equal to expectation of x.
Yes, sir.
It's 1 by lambda.
Yes or no? So
Yes.
if you see the formula, not formula, you can see what we have to do. This is the kth we have to give. We have been given in general kth. Okay, forget about this. So if you see, so what is, okay, let's try to do. So what is the 1 upon n summation of xi, right? Let's try to do what is the expectation of x for exponential distribution if x follows
1
exponential.
by
Lambda.
So expectation of x is 1 by lambda. So it will be 1 by lambda. So basically this is summation of xi divided by n equal to 1 by lambda. So lambda hat will be what? N divided by summation of xi.
Yes, sir.
So lambda hat means value estimator. I mean value, you are estimating this. N is how much? 6.
6.
What is the summation of xi? Summation of xi means
100.
15 plus 20 plus 15 plus 16 plus 14 plus 20, which is 100, right? So 6 divided by 100, which is 0. So that is the answer. You can see how simple is it. It will take only 2 minutes. Is it clear?
Yes, sir.
Yes.
Right? You can see this is very simple, right? Okay. If you want a great discussion about why we are equating this sample moment to the population moment, we can have a separate session. Okay. I think for today we can focus this kind of basic thing. Okay. Is this
So
all right?
sorry.
Okay.
All right, sir. Actually, sir, my net got disconnected. Can you just repeat little in short, sir? This question, sir, only.
Okay,
my-
so we have to estimate the lambda. What is the to estimate one parameter? I told you we have to equate first sample moment to the distribution moment or population moment. So what is the M1? M1 is 1 upon n summation of xi and expectation of x. So what is the expectation of x? You can see in the question it is mentioned it's the exponential distribution. So expectation of x in case of exponential distribution is 1 by lambda only. So M1,
Right.
this is M1 equal to 1 by lambda, and from where I will get lambda at as a 1 n upon summation of xi. And what is the n? N is 6. 1, 2, 3, 4, 5, 6. 6 divided by summation of xi. This is x1 plus x2 plus x3 plus x4 plus x5, x6, which is 100, and value will be 0.06, which is the okay.
Fine, sir. Thank you, sir.
So next
So
is
in the same question, sir, if they ask for the second moment, would that be would they like specifically
no.
say
Here, how you can't find the second moment, right? So basically, I mean, you can find. It's not like you can't find, but basically, when we are using the second moment, whenever you have two parameters, right? I mean, suppose you want to estimate two parameters. So to estimate the two parameters, you need two equations, right? Are you getting my point? So basically you can find, it's not like you can't find. So what is what you will do? You will do 1 upon n summation of xi square equal to expectation of x square, right?
Okay.
In case of second moment, right?
Yeah.
Okay. But here you have to estimate the lambda only. I'm just explaining whatever the your question. How you can find the expectation of x square? I can write variance of x plus expectation of x whole square.
Yeah.
Right, and then you just square this value, divide by 6, and variance of x is 1 by lambda square plus 1 by lambda whole square, basically 2 by lambda square. Then you will get some equation you have to solve. Okay.
Okay. Got it.
So basically second moment is helpful whenever you have been given two parameters. Let's say in case of binomial, right? If you have been given binomial or gamma distribution, if I'm saying x follows gamma distribution, two parameters alpha and beta, since you have to estimate these two, then what you need two equations, right? Then you will do one of m1 equal to expectation of x, and then you will do m2 equal to expectation of x square, and by using these two equations you will find alpha at and beta at. Clear?
Okay. Got it, sir.
Yeah. So
Thank you.
the next thing there is on the this is maximum likelihood. I will come to this question in a minute. So this is another question. Okay. The probability mass function of a random variable x is given as like this. So there is a one you have been given a random sample. You have to find the method of moment estimate for theta for this sample, for the given sample. Tell me, what is there is only one parameter, right?
Yes, sir.
That
Yes,
means
sir.
what I have to do, I will equate m1 equal to expectation of x, right? Yes, no.
Yes, sir. Yes.
Then
Yeah,
what is
correct.
the m1? M1 is 1 upon n summation of xi equal to expectation of x, right?
Yes.
Yes,
So
yes,
this
sir.
n summation of xi n is what? Basically this is x1, x2, x3, x4, x5, x6 up to x10, right? So this is something summation xi by n. But what about expectation of x? Here it is not mentioned it's from exponential or it's from Poisson or any other distribution, right? That means you have to calculate the expectation of x,
Yes, sir.
correct?
Correct.
And since this is a discrete random variable, what is the expectation of x? It will be summation of x into probability that x equal to x. Yes or no? This is
Yes.
something expectation I can calculate. Are you getting my point, everyone? So what is
Yes.
the expectation of x? It will be 0 into 2 theta by 3 plus 1 into theta by 3 plus 2 into 2 1 minus theta by 3, yes or no? This into this plus 3
3
into 1
into
minus theta
1
by
minus
3.
theta by 3.
Is this clear? This part is okay to all of you? So this
Yes,
will be
sir.
0, it will be theta by 3 plus it will be 4 1 minus theta by 3 plus 3
And
1 minus
1
theta by 3.
1 minus theta, sir.
So it will be expectation of x will be what? If you see the numerator part, it will be theta plus 4 minus 4 theta plus 3 minus 3 theta divided by 3. So it will be 3 minus 3, 7 minus
7 theta.
6 theta divided by 3,
Sir,
right?
7 theta, sir.
No,
Oh, 6 theta. Yes, yes.
yeah, there is one more theta, right? So if you see what we have to do, I have to equate m1 equal to expectation of x, right? And what is the m1? 1 upon n summation of xi equal to expectation of x. We got 7 minus 6 theta divided by 3. So what is the m1? If you see, we have to find the average of this value, right? So if you see, this is 101. So basically what it will be? It will be 1 plus 0 plus 1 plus uh, 2 plus 2, right?
13.
Plus 0 plus 3 plus 1 plus 2 plus 1. So are you able to interpret, right? What is the equations we are writing, or is there any doubt?
No, sir.
All right. So I mean, what is the like meaning of given equations and all, right? I mean, how to interpret which value and all, everything, right? So
Yes.
now from here, what is the summation? It's 2
13, sir.
13, right? So 13 by 10, it will be 7 minus 6 theta divided by 3. So from here, it will be 1.3 equal to 7 minus 6 theta divided by 3. So we got 3.9 equal to 7 minus 6 theta. So it will be basically 6 theta equal to 7 minus 3.9. 7 minus 3.9 will be 3.1. Okay, so here 6 theta is what? 3.1. So value the theta, basically theta had 3.1 divided by 6. So basically it's 0.51 something, right? So 152. If you do till the decimal places, so you can see 0.5 is done. Is this clear, right? Any doubt?
No, sir.
No, sir.
Okay, so if that is clear, so just try this question and do not tell me this answer directly without trying. Okay, so or should I do?
No,
Okay.
sir. Let us try.
Yeah, just try once, right? You will get some idea. See, one more thing I can say, if you are able to do this question and the which question I just explained, then you will for sure you will be able to do it during the end term exam related to this question. So there is very similar question to this.
So done.
Done, sir.
Okay, so you are getting the same answer, or
Yeah,
Yes, sir.
correct.
okay, you are able to do, right? Then I will quickly go through and I will not solve the whole question. Okay, then I will move to the next topic. Okay, basically what you have to do, you have to calculate only one parameter, which is P. Then what you have to do, basically I will do M1 equal to expectation of X. What is the, basically I will equate first sample mode. This will be 1 upon n summation of Xi equal to expectation of X, right? And what is the, this value I can calculate from this sample, right? Basically I have to do 0 plus 3 plus 2 plus 2 up to 0 divided by 10. Right? I think 10 values are 3, 3, 6. Yeah, 10. And but what is the expectation of X? This is because basically this is not mentioned any specific distribution. So expectation of X, we will go with the usual formula, X into probability of X equal to X. You will do 0 into P by 4 plus 1 into P by 4 plus 2 into P by 4 plus 3 into 1 minus 3P by 4. And this value, this expectation, you will equate with this value, and I mean summation of the all these value divided by 10, and you will get at the end P as a P hat as a 0.8. Okay, is this all right?
Yes, sir.
Yes, sir.
Okay, then let me discuss the next concept, which is called ML estimation. Okay, maximum, basically MLE, maximum likelihood estimation. Okay, so this topic, this MLE is very, very, very important as exam point of view, as well as in the field of data science. Okay, so whenever you will learn, I mean, whenever you will move to the machine learning part, right? So this MLE plays a very important role there. Okay, you will find in machine learning course, you will find in degree level courses called statistical computing, and also basically this MLE concept is very, very important. Okay,
Sir,
so
what was its full form?
I think you shouldn't ask this question, right? Because that
Sir, I
means you
forget. Sir, we
this,
often forget this full form.
yeah, then it's okay. So because it's, that is something you did.
Maximum likelihood
Yeah,
estimation.
so
Estimator.
M stands for maximum, L is for likelihood, okay, for estimation. Okay, so basically if you see the name, you have to maximize the likelihood function. Okay, but basically what is the likelihood? So likelihood, meaning of the likelihood is nothing but basically you are interested what is the probability of observing your samples. Okay, so likelihood will give you the idea what is the probability of observing, okay, my samples, okay, for a given theta, I mean for a given value of your parameter. So basically you are interested to know this likelihood, but how you can calculate this likelihood? If you see, I'm interested to know the probability of probability for my sample. So basically suppose I'm saying I have x1, x2 up to xn. These all are IID samples from some distribution x. And for this x, let's say I have parameter theta. Okay. Then basically, let's say for this x, in general, you have some parameters. I mean, here theta 1, theta 2. So basically, in general, we are saying, right, x1, x2, xn are IID from normal mu comma sigma square. So you can treat theta 1 as a mu, sigma square as a theta 2, something like this. Basically, then what will the CDF, PDF? PDF we are writing fx as a x something, right? Like, yes or no? This is just a notation to denote the PDF, right? Then what is the likelihood? So likelihood, I told you what is the likelihood, if what is the meaning of likelihood? Observing your sample, right? So let's say I have one sampling instance, let's say for all those random variable, let's say x, small x1, small x2, small xn. Okay, then likelihood of these samples will be what? This is nothing but product of, okay, let me write like this. So basically I will do what is the PDF at x1, at x2 up to, let's say, for xn. Basically I'm going to observe my samples, but I'm interested to know what is the probability of observing my samples for a given theta. So in general, I will write product of I is equal to 1 to n fx of xi. And here you can write just a notation of parameters also. Okay, is this clear? This is the likelihood. And what is the if you see the name is called maximum likelihood. Basically, I want to maximize the likelihood. Okay. One more thing, can you tell me when you will find a maxima of any function? How you can find? Suppose you have function f. How you can find the maxima?
You differentiate for the function
And
and equate it to 0,
why we are equating to the 0?
because that is
To
the
find
way
critical point.
it will be changing the direction, so it may tend to be maximum or minimum.
Correct. Suppose my function is this kind, right? Then maximum will occur somewhat here. And at this point, slope is 0. Yes or no?
Yes.
And slope is 0. Since slope is 0, that means I will say the differentiate with respect to that parameter I will take is equal to 0. And that's why we are saying it's equal to 0. And since it's the maxima, then second derivative should be less than 0. Right? Okay.
Yes.
That is something mathematics. Okay. Let's but here I want to maximize this likelihood. The one more thing, but sometimes maximizing this likelihood, differentiating this likelihood function with respect to theta, it's difficult. I mean, you will get some difficult formula. I mean, it involves some complicated. The thing is, one mathematical concept is maximizing the likelihood. Okay, is same as maximizing the log likelihood. Okay, means log of that likelihood function. Okay, so that's why we are taking log of that likelihood and then we are maximizing that function. Okay, so let's try to see one example. Okay, basically we will take the log of that function, then we will equate with the, I mean, we will differentiate with parameter and then we'll go for the further. Is this clear?
Yes, sir. I have a question. Like
Hmm.
in a week, we have studied na posterior equals to likelihood. So that likelihood and this likelihood both are same, right?
Yeah, likelihood the same, right? You can so I mean this is something you are saying you done mean in week 2 and again mean in week 3. So both are different. No. So that is the same. I will come to that point. No worries. Okay. Anyway, I'm going to discuss the week 10 content also. Okay. Let me quickly do this. Okay. All right. So suppose I'm
Yes,
saying
sir.
I have x1, x2, so on, xn. These all are from IID, let's say Bernoulli with P. And I have to find the maximum likelihood estimate for P. Okay. So suppose I'm saying the samples are given to me. Okay. Samples are small x1, small x2 is up to small xn. Okay. Just assume you have some samples, let's say something like this. This is Bernoulli, you will get sample like this, right? Yes or no?
Yes, sir.
Now, just assume here you are getting W time one, how many times? Let's say W times. Okay. And 0, how many times then? N
N
minus W,
minus W.
Minus W.
right? So N can be anything. It can be 50, 100. Okay. So I'm just going to do in general. Okay. So what will the likelihood? I told you likelihood of your samples is nothing but what? It's the product of fx of x1 up
Yes.
to fx of xn, right? So what is the PMF for Bernoulli distribution?
P.
PX.
Okay, basically what you have to do?
For
Basically,
it
I
is
will,
one
okay,
P.
suppose P times, sorry, W times we are getting P, okay? Or sorry, 1. That means I have to,
P
I'm
power of
interested,
W.
yeah, yes, basically I will do P into P into P, how many times?
W times.
W times.
W
W.
times. If you see what is the probability of observing my sample, so this is my samples, right? This is the probability,
Yes.
and n minus p time, sorry, n minus w times p,
1
right?
minus. Yes, sir.
Sorry, 1 minus p. So this will be p raised to power w, and it will be 1 minus p raised to power n minus
N
w,
minus W.
right? This is my log. So sorry, not log, likelihood. So next step, I will take log of this function. Okay. So what is the log of this p raised power w into 1 minus p raised power n minus w?
Yes.
Log of a into b will be log of
Log of A
a
plus B.
plus log of b.
B.
Right. So,
Yes.
and this power will be w times log of p plus n minus w of log of
Log of
1
1
minus
minus
p.
50.
Is this clear till now?
Yes.
Now, next, what we would do to find the maxima, we have to differentiate with respect to
P.
p, because I want to estimate of p. Then this will be w by p plus
Yes.
Yes.
n minus w divided by 1 minus p,
1
because
by P.
differentiation of log x is 1 by x. Now this is 1 minus p. Again, you have to differentiate 1 minus p. You will get minus 1.
Yes, sir.
And this
Yes.
is something you have to equate with 0. So this will be w by p equal to n minus w divided by 1 minus p.
1 minus P.
Yes,
So
sir.
next step will be w into 1 minus p equal to np minus wp. I mean, basically, I
Yes, sir.
did the cross multiplication, right? So this will be w minus wp equal to np minus wp. You
W.
can see wp will get cancelled out, so we will be having w equal to np.
NP.
So p hat will be w by n. So what is the
W by N.
w here? Number of
Success.
Successful.
ones
Successful.
divided by n. So suppose you have been given some 10 samples, let's say 1, 1, 0, 0, 1, something like this. Then what will the p hat here? It will be 4 by
4 by 6.
6.
4 by 6.
Is this clear?
Yes, sir.
Okay.
Only sir, one negative sign. How you change? How to just little last, just above, sir.
Mhm.
Above. Sir. How you said minus one, n minus w divided by 1 by p into minus 1. How you got this, sir?
See, if you are differentiate log x, it will be 1 by x.
Exactly, sir.
Instead of x, I have 1 minus x. It will be 1 minus x. Since I'm doing with respect to x, not with respect to 1 minus x, then you have to again differentiate this 1 minus x. It will be minus 1. Okay.
Chain rule, basically.
Chain rule. Basically, you have to apply chain rules. Yes.
Okay.
Okay. Is this clear?
Yes, sir.
Yes, sir.
Okay. Then let's try to do the question which your no, seniors have done already. Okay. So let's try to this question. So this is something amount of time in minutes a postal clerk spends with a customer follows an exponential distribution with parameter lambda. The timings in minutes is given for a sample of 5 customers. You have to find the maximum likelihood estimate of it, lambda, not theta. So what you will do first of all? So let's do in general. So in case of exponential, if I'm saying x follows exponential with parameter lambda, then what is the PDF?
E to the power minus lambda x.
Lambda into e raised to power minus lambda x, right?
Yes.
Yes.
So what will be the likelihood? That means L. So it will be I is equal to 1, 2, and let's do in general first of all. Okay. Suppose you
Yes.
have n samples. Let's do in general. Then I will do fx of xi. Yes or no? Basically, I'm multiplying fx of, see, here you have x1, x2 up to x5 only, right? I'm doing till xn, that's all. Okay. So if you see, then it will be basically what you are doing here. Here you are doing fx of x1 into fx of x2 up to fx of xn, right? You are multiplying till n. So if you see, what is the PDF? So it's a lambda into e raised power minus lambda times of xi.
Yes, sir.
Yes.
If you are not getting, just let me know. So this means what? Lambda into e raised power minus lambda of x1, then lambda into e raised power minus lambda of x2 up to lambda into e raised power minus lambda of xn or not? Right?
Yes.
Yes.
Now
Yes.
this is lambda raised power n
N.
and e raised power
E to
minus
the power
lambda of
minus
x1
lambda
minus lambda of
summation
x2
xi.
minus up to lambda xn. Power will be
Yes.
added or not? See, if you have e raised power a into e raised power b, I can write e raised power a plus b, right?
Yes,
Yeah.
sir.
So if you see, this is lambda raised power n. I can write minus lambda. I can take common. Then what will be? It will be
Sigma summation
Summation of it of xi.
xi, right? This is your log likelihood. What will be the log of this? It will be log of lambda raised power n plus log of e raised power minus lambda times of summation of xi. So
Yes.
just make sure this is natural log with base e. Okay. So this will
Yes.
be n times of log lambda.
Yes,
And
sir.
you know log of e raised power x with base e nothing but x only.
Yes,
Yes.
sir.
This will be minus lambda of summation of xi. So far
Yes,
so
sir.
good. Now, what is the next step? I have to differentiate with respect to
Lambda.
lambda because I want then it will be n by lambda
Yes, sir.
minus it will be summation of xi, and this is
Yes, sir.
something I have to equate with 0. So this will be n by lambda equal to what? Summation of
Summation of xi.
lambda will be what? Lambda at n by summation of,
Summation of xi.
and this is in general. If you take for 5 samples, so lambda hat you got n divided by summation of xi. Then what is the n here? 5 divided by summation of each xi, which will be 13 plus 10. So 1326, 14, 40, and divide by 65. So 5 divided by 65. How much?
1/13.
1/13.
I mean, in terms of
076.
point 0 point
076.
076, that is 0.08. We have to correct up to 2 decimals. So now is this clear, right? Any
Yes,
doubt?
sir.
So,
Any doubt now?
No, sir. All clear.
Clear? Okay. So if this is clear, then what about this question? How will you proceed for this question? I mean, let me write this part only. 0, 1, 2, 3, 2 by 2 theta by 3, theta by 3, 2. Okay. So you have been given x is defined as 0, 2 theta by 3. So this is the probabilities, and 1 theta by 3, 2, 2, 1 minus theta by 3, and for 3, this is 1 minus theta by 3. 1 minus theta by 3. Yeah. So how
so
will you proceed for this?
calculate first number of ones, number of zeros, number of twos, and number of threes.
Okay, so basically, okay, tell me what is the first step? Basically, what you have to find. So in likelihood, what we are doing? Tell me. In likelihood, we have to what we have to do? We have to multiply the probabilities for each sample.
Yes.
Yes or no? This is something we have to do, right? Everyone is getting my point. So if you see here, we have samples 0. Okay, what is the possible values? 0, 1, 2, and 3, right? So how many times 0 is occurring? We have done in case of Bernoulli. So in case of Bernoulli, if you see how many times 1 was occurring? P times, sorry, W times, right? And we multiplied the corresponding probabilities for ones. We multiplied the corresponding probability for zeros, right?
Yes, sir.
Basically, what? Okay,
Yes,
okay,
sir.
okay. If you talk in general, then what you are doing? Suppose this is the samples. This is samples you have observed. What will be the likelihood of this sample? So it will be, okay. Let me write maybe that 1 1 0 0 1 1. So suppose this is your samples. What is meaning of likelihood? Fx of x1, fx of x2, fx of x3, up to fx of x6, right? 6 samples. So what is the probability for observing one? So this means what is the probability for x1? So this is p. This is p for 0, 1 minus p for 0, 1 minus p for 1, p into p. So at the end you can see how many times p is there? 4 times, and 1 minus
4
p. How many?
times. 2
That is
times.
something we have done, right?
Yes, sir.
Now
Yes, sir.
here what you have to do? What will be your likelihood? So how many times 0 is there? Okay. Basically, what you have to do
2
for
times.
3? For 3, it's a 1 minus theta by 3. Correct? Into. Basically, what you have to do? You have to do till 10. I think 10 samples are there, right?
Yeah.
So what is the fx of x2 for 0? It's a 2 theta
2
by 3.
theta by 3.
Basically, then for 1,
Theta by
theta by
3.
3. For 2, 2 into 1
2
minus
into 1
theta by
minus theta
3.
by 3.
Again for 3, 1 minus theta
1
by
minus
3.
theta by 3.
Basically, we have to multiply how many times 3 is there, how many times 0 is there, right?
Yes, sir.
Okay.
Yes, sir.
So if you see, I'm just erasing this part. So if you see how many times 0 is there,
2
1
times.
time.
2 times 0.
So this will be
2 theta by 3
to the
square or
power
not?
2.
Okay, just let me know if you have any difficulty at this point, right? And since 1 is also there, so how many times 1 is there? 1,
3 times.
2, 3. What is the probability for 1?
Theta by 3.
Theta by 3 whole cube.
Cube. Yes, sir.
Okay. What about 2? 1, 2, 3.
3 times.
2, 1 minus theta by 3
By
whole
3
cube.
whole cube. Yes,
Because
sir.
3 times you have to multiply. What about 3? 2 times.
2 times. 2 times.
Right. So it will be, what is the probability for getting 3? It's 1 minus theta by 3. It will be 2. Is this clear?
Yes,
Is
sir.
this clear to all of you?
Yeah.
Yes, sir.
Okay.
Yes.
Then next step will be just take all constant together, because when you will differentiate, it will be 0, right? So first of all, it will be 2 raised power 2 and 2 raised power cube and divide by 3 raised power 10, right? If I'm not wrong. And what else you will get? Theta square into theta cube into 1 minus theta whole cube and 1 minus theta whole square, right? So just I'm writing this as a constant c. So L will be c into theta raised power 5, 1 minus theta raised power 5. Yes or no? One more thing you can cross check. Maybe
Yes, sir.
sometimes we miss the number of samples. You can see 10 samples. If you will add the powers, it should be 10 also. Okay. So what is the next step? You have to take log. Okay, so it will be log of c plus log of theta raised power 5 plus log of 1 minus theta raised power 5. Yes or no? Then this will be log of c plus 5 log theta plus 5 log 1 minus theta. Any doubt?
No, sir.
Yes, sir.
So next step, what we have to do? We have to differentiate with respect to theta and equate with 0. Then if you do differentiate this constant, you will get 0, right? And this will be 5 by theta plus 5 by 1 minus theta. Log of 1 minus theta will be 1 minus theta, and you have to again do 1 minus
Minus 1.
theta minus 1
Minus
to equate this as a 0. Then next it will be 5 by
5
theta equal to
equals
5,
to 5
1 minus
of 1
theta.
minus
So
theta.
basically your 5 will get cancelled out. Basically you will get the 1 minus theta equal to theta. So it will be 1 equal to 2 theta. So theta hat will be 1 by 2. So which is, you can see option C is the correct. Any doubt?
All are clear. The L where you have given 2 square, 3 square. Can you? How did we?
Yeah, this is just 2 square, right? If you take 2 outside and 2 cube, that's all.
Okay. Sure.
This is just constant. Anyway, this is going to be 0.
Got it.
Okay. Okay. So what about this part? This question. Okay. Let me write. It's a p by 4, 1 minus 3p by 4. So for 0, it's a p by 4. For 1, it's a p by 4. For 2, it's a p by 4. For 3, it's a 1 minus 3p by 4. Basically, what will be your likelihood here? It will be for 0, how many times is there? 2 times. So it will be p
times.
4 square 1
Yes, sir.
p by 4.
1 times.
2 how many times? Again 2 times.
2 times.
And 3 how many times? 5 times, right?
5
So it will
times.
be 1 minus 3p by 4 raised power 5, right? So it will be p raised power 5 divided by 4 raised power 5 into, here it will be 4 minus 3p raised power 5 divided by 4 by 5. So this constant, whenever you are getting too much constant, just take as a single quantity, because anyway it is going to be 0. If you differentiate with respect to p, it will be p raised power 5 and 4 minus 3p raised power 5. This is log. Is this clear?
Yes, sir.
Yes, sir.
Whenever you will solve, you will get the final answer. Okay. Any doubt in this likelihood? Will you able to do this question, this kind of question or not?
Yes, sir.
Okay. Then you will get good marks. Okay. Okay. Suppose one more idea. If I'm writing like this, instead of this, suppose I'm saying I have 10 IID samples in which, let's say I'm saying 0 occurs 5 times, 1 occurs 3 times, 2 occurs 2 times. This means what? Suppose for 0, probability is p by 4 only. Then you will write p by 4 raised power 5.
Yes, sir.
1 will be p by 4 raised power
4 3.
and for 2, 1 minus whatever the probability. Okay.
Yes, to the power 2.
Yeah, whatever. So I'm not going to solve this question. Okay, I'm just assuming is this will you able to do it, right? Any
Yes, sir.
doubt in this week 9? Okay,
No, sir.
so
All clear.
then let me start the week 10, which is also very important part. Okay, so okay, how many of you got the concept of week 10 by the as usual sessions which we are done? Are you okay with that or any doubt?
It was difficult to understand the concepts.
Okay. You didn't get at all, or you got, or you are.
Sir, week 10 was that now? Posterior equal to likelihood into prior.
Yeah.
Yeah, sir.
Yeah, prior was there and all.
Prior and
So, I mean, I understood the concept and all, but when it comes to solving the question, I'm not able to use those concepts to solve the question.
Okay, no problem, no problem. So what I will do, I will quickly go through the concept and then I will solve the. Okay. Okay, I will solve some questions. All right. Okay. So in parameter estimation, right? So let's try to understand the idea behind this Bayesian estimation, because for parameter estimation, we saw the method of moment, right? We saw the maximum likelihood estimation, right? We saw the scenario for this, we saw the questions for this also. But what about suppose there is some other scenario? Okay, some other what I mean by the scenario, suppose there is okay, let's try to understand the situation. Okay, when this Bayesian estimation is helpful actually. Suppose I'm saying you are going to estimate the unknown, right? Suppose I'm saying x1, x2, you have this IID from your x. Okay, or let's say let's make it certain. Let's say this is Bernoulli P. Okay, and I know what is this P. This P is probability of getting one, right?
Yes,
Yeah,
sir.
no. So what is this actually? What is the idea behind Bayesian? If anyone, any idea, just wanted to listen. See, anyway, you can solve the questions at any time, but the key thing is we should get the concept. So what is the idea behind Bayesian estimation, or in which scenario we can use?
Sir, in this, the parameter is not constant. It is a random variable.
Random.
Okay, why we are considering as a random variable?
It is following some distribution. The parameter is also following some distribution.
Prior distribution.
Okay. Okay, yeah, let me tell you. So basically, suppose I'm saying, suppose you are an analyst and you have lots of experience with real life, data and all something. And for that particular scenario, you are saying, suppose as an analyst or as a statistician. Yes, Shivam.
Sir, can you explain this concept with this frequentist and Bayesian theory like this something?
Yeah, welcome to that. Let me basically. So I'm basically focusing on the exam point of view, but I will explain.
Okay, sir. Thank you, sir.
Suppose you are an analyst and with your experience and all, prior experience and all, you are saying you have believed that. I believe that this, suppose this, you see, you can't say this is unbiased, right? You are not saying this is unbiased. If you are saying unbiased, then this P will be half and half, right? Suppose you are saying you have believed that this bias P is somewhere close to 1. Okay, this is just a belief, right? Basically, or you can say you basically you have an idea, or you can say you have a thought about your parameter, right, from your prior experiences, right? Okay, that is something. Suppose you are going to do any real life analysis and all, you are saying, oh no, my belief is saying this bias P is somewhere close to 1. Okay, basically this P follows some distribution, this can be close to 1, something like this, right? The thing is, then what is the procedure? So the key idea is you to check, is there any principled way? See, the some You can't say anything in air, right? You have to find, is there any principled way, okay, in which, okay, I can incorporate, what you can incorporate, let's say your belief, okay, whatever the belief you have, along with data, okay, into our estimation process. Okay, so this is something you can treat as a your goal. Okay, means you have some thought, you have some belief, you want to know whether there is any principled way or not in which you can incorporate your belief along with data, right? I mean, you want to check your belief basically. So you are saying your p is somewhere close to 1, right? So basically you are saying, let's say this is 0 and this is 1. P is close to somewhere 1 means P is following some kind of this distribution, I can say, right? Yes or no? Or your P can
Yes,
be,
sir.
this, suppose this is 0, this is 1, it can be something like this also. Yes or no? I mean, it can be anything. So basically, you want, whatever the belief you have, you want to incorporate along with your data. Okay. So basically, this can be anything, right? If it's close to 0.9, it can be this kind, it can be this kind, it can be anything. Okay. So basically, what you are going to do, okay, I explained here only, right? Okay. Okay, let me write here. I think I should. Okay, so what you have to do basically, basically the whatever the you just treat your belief. Okay, so as random variable you can treat or not. Tell me, because it can be any form, right? Yes or no?
Yes,
So
sir.
Yeah.
you are treating as a random variable. That means you are saying which has some distribution associated with it, right?
Yes.
Now, basically, what you are doing in general, so whatever the belief you have, you are going to codified. Uh, Please let me know if you are getting any confusion. So basically, what you are going to do, you are going to codify your belief using a probability distribution of your parameter theta. Okay, so basically there will be some prior information. Okay, you are saying you have some prior information about your parameter theta. Okay, prior information, or your, or you can say prior distribution. So what you are going to do basically, so in Bayesian estimation, what we are going to do, so you have some prior information and you will be having some sample data, and by using this data you are going to update your belief. Are you getting my point? You have a prior
Yes.
information, you are going to use some data. By using this data, you are going to update your belief. So basically, what you are going to do, meaning updating your belief, that means you are going to find for a given data, what will be the value of parameter? Yes or no? Are you getting my point? So this is something you are going to do, and this is nothing but this is called Bayesian estimation. Okay, so you have some prior information, you have some belief, you have sample data. Based on this, you are going to update your belief, you are going to check. Okay, I mean, given your data,
Yes.
what will the value of your theta? Okay, is this clear?
Yes, sir.
So this is
Yes, sir.
nothing but this is something called posterior distribution. Okay, so if you see the Bayes theorem, actually, okay, what is the meaning of posterior distribution? Basically, this represents the updated knowledge about parameters after observing your data. So if you can relate this mathematics equation, so this represents, okay, what it represents? This represents what is your updated knowledge, or you can say updated information, updated belief about what? About parameter theta, right?
Yes.
About parameters after when? After observing the data. Okay, the basic idea is clear about this parameter estimation? I mean, you had some prior belief, you use your data to update your belief, to check your updated knowledge. Yes, no, any doubt?
Yeah.
Yes.
Right.
Thank you.
So if you see the Bayes theorem, right? So we did Bayes theorem. Okay. So in Bayes theorem, probability A given B is what? It represents probability of A intersection B divided by probability of B, right? And if you
Yes,
see the
sir.
numerator part, I can write probability of B given A into probability of A divided by probability of B.
Yes, sir.
Okay.
Yes, sir.
Here what you can do, basically you can treat your A as a parameters, which is theta, and you can treat your B as a data. Okay, and data is what? Let's say x1, x2 up to xn. In general, let me write as a S means sample data. Okay, then what else I can write from here? So what is the probability for theta given that my data, I mean sample, this is equal to probability that data, I mean sample, given that theta into probability of theta divided by probability of this x1 up to xn, right? I mean basically probability of
Yes.
theta. Okay, so you can see, okay, this numerator part is always independent of theta, right? This is just sample observations, right? Okay, so can
Yes.
you say probability of theta given I'm just writing data, this is proportional to probability of data given theta into probability of theta?
Yes, sir.
Oh, this is just a constant. I'm not writing equality sign, I'm writing the proportionality sign, right? So this is what called posterior distribution. So this posterior distribution is proportional to, this is called likelihood, right? Yes or no?
Yes.
Into this is prior distribution, means you have distribution of your theta. So this likelihood you have seen, right? So what is the meaning of this probability of data given theta? Means for a given theta, what is the probability of observing your sample, basically, right? So this means probability of observing your sample. This is something, right, we have done just a few
Yes,
minutes
sir.
before for likelihood, right?
Yes, sir.
Okay, is this clear? Idea behind this
Yes, sir. Thank you.
uh, what's called Bayesian estimation, right? What is the key idea behind,
Yes.
right? Okay, all right. Is this fine, right? Any doubt?
Yes, sir.
Yes, sir.
Yes.
Okay,
Yes, sir.
it's clear, right? What is the key idea?
Yeah, all clear,
Okay,
sir.
okay. Then let's do this question. Okay, then it will be okay. So basically, if you see the question, okay, this is important again, very important. Okay, so we wish to estimate the probability P of getting number 5 on a biased die using a Bayesian estimator. Consider 10 independent throws. Let x be the number of times 5 appears on the die. Okay, what is the x? X represent the number of times, right? 5 appears on the die. Okay, then what will the distribution of x? It will be binomial
Binomial NP.
n comma p, right?
P.
And it says a prior distribution of p is beta 2 comma 2. So p of p, should I write like this, or if you're getting, so prior is what? Beta 2 comma 2. So out of 10 throws, if 5 appeared a total of 4 times, then find the posterior distribution. Okay, first of all, out of 10 throws, so there were n equal to 10 throws. So for 10 throws, you can consider like this. Out of 10, how many times 5 appears? 4 times, right? That means 4 times you got P,
Correct.
right? 4 times you got success, right?
So remaining 1 minus P 6 times.
6 times, right? So that means this means 4 times. What is your success? Success is nothing but getting 5,
Yes.
right? And failure is another number, right? So if you see, what is the likelihood? First of all, if you see, likelihood is what? Observing your samples, right? So what is likelihood? It will be
E to the power
p
4.
p raised for 5.
4, sir.
Sorry, p raised for 4.
Yeah. into
sorry, 1 second. Let me write like this. It will be p raised power 4 into 1 minus p raised power 6, and here it will be 10c4, right?
Yeah.
If you are using the binomial, forget about this. Let's talk about proportionality sign, because we don't need. Okay, so basically this will be likelihood, right? So if you see, what is the posterior distribution we have seen? Posterior is proportional to likelihood times prior, right? We are not
Yes.
going to deal with constant here. So basically, what is the likelihood? 4 times p, and remaining will be failure. And if you see the prior, right? Prior distribution is beta 2 comma 2. So if you see, beta will be given to you. Okay, so if you are see the form of beta. So first of all, this is the constant, right? We have to
Yes, sir.
focus here. Okay,
Right.
we have to focus here only. X raised to power alpha minus 1. Basically, if you have, I'm saying X follows, let's say beta distribution with parameter alpha comma beta, then I'm writing f of x is proportional. I'm just ignoring the constant. It will be x raised to power alpha minus 1 and 1 minus x raised to power beta
Beta
minus 1.
minus 1.
Right? So here instead of x, what we have p, right? Because we are
Yes, sir.
treating p as a random variable, because it says p is the beta 2 comma 2. So it will be p raised to power 2 into 1 minus p raised to power not 2, 2 minus 1 into 2 minus 1, because it says
Yes, sir.
alpha minus 1 and beta minus 1. Is this clear? If you
Yes,
see,
sir.
now this will be p raised to power 4 plus 2 minus 1 into 1 minus p raised to power 6 plus 2 minus 1. This is proportional to p raised
Yes.
to power 6 minus 1, 1 minus p raised to power 8 minus 1. So you can see this is form of again beta.
Yes, sir.
Yes or no? Because if I'm saying x follows beta, let's say with parameter alpha comma beta, then f of x will be proportional to x to power alpha minus 1 and 1 minus x to power beta minus 1. Is this clear? So here instead of x, what we have? We have p as a random variable. So what will be the posterior distribution?
Beta
Beta
6 8
6
alpha 8.
comma 8.
So sometimes people make mistake. They write this as a 5 comma 7, which is also in the option. You will think this is the correct. No. So 6 comma 8 is the correct. Okay, because it's the power alpha minus 1 and 1 minus x raised power uh, beta minus 1. Is this clear?
Yes, sir.
Okay. So if you see, the next question is the posterior
Sir,
mean
can
using
you
the.
just, sir,
Yeah.
can you just show the question, previous question, just question, sir? Yeah. 1 second.
Sir, last you how you last point, sir, you told just repeat, sir. Last point.
One by one.
Sure, sir. I'm done. Thank
Done. Right. Yeah. Where you are doubt?
Sir, how you got, sir? 6 minus 5. You told 6 minus 5 is not 5.
No,
This
so,
yeah.
okay, what I'm saying, this will be p raised power 5, 1 minus p raised power 7, right? So
Yeah.
sometimes people directly write 5 comma 7. No, this is incorrect, because in power it should be alpha minus 1 and beta minus 1. So for 5, it will be 6 minus 1 and 8 minus 1. Okay. So don't write 5 comma 7. It will be original will be beta 6 comma 8, right?
Thank you.
Yeah. So if you see the next question, so it says find the posterior mean using the correct prior. So what was the prior? Prior was beta 6 comma 8. And you know, if you have beta alpha comma beta, then what will be the expectation of x here? Alpha divided by alpha plus beta. If you don't able to recall, don't worry, here it is given, right? So what is
Yes.
the alpha? So here posterior mean will be 6 divided by 6 plus 8. So 6 divided by 14. So you can solve this, and 6 by 14 will be how much?
0.4.
0.42 something, right? 428. So if you approximate to 2 decimal place, it will be 0.43. Any doubt?
No,
No.
sir.
Okay.
Sir, what do you mean by correct prior? So
Correct prior. Okay, correct prior means all the prior. I mean this p beta 2 comma 2. I mean this is just for okay. Basically, okay. Sometimes you like you don't know, right? No, no, no. One second. What is the statement?
I think correct price is
Posterior
calculated.
choosing. Yeah, correct prior from the above. Yeah. I think it's talking about this prior, choosing this prior. What is the correct posterior actually? Okay, you can ignore that one. That's not a big deal. Okay. So okay, key idea is clear, right? So what we have to do? We have to find the posterior, which is proportional to likelihood times prior, right? And for this
Yes, sir.
question, okay, let's do for this question. What is the prior? Prior is gamma 5 1, right? And if you see the gamma distribution, so this is gamma alpha comma beta. Alpha beta are the parameter. They are called shape and scale parameter. Don't worry about those wording. So if you see, this is the constant, right? Beta is for alpha, gamma alpha, right? We can ignore this part.
Yes.
So I can say fx will be proportional to x raised power alpha minus 1 e raised power minus beta x.
Yes, sir.
Right? If I'm saying this is gamma alpha comma beta, so fx is proportional to what is this? X raised power alpha minus 1 and e raised power minus beta x, right? Here lambda follows gamma 5 comma 1. Then what will be the f of lambda? In the prior distribution of this, it will be lambda raised power 5 minus 1 e raised power minus lambda, because beta is 1 only. Any doubt? Instead of x, we have lambda.
Yes, sir.
Correct? Are you getting my point here?
Yes, sir.
Yes, no, this is prior, right?
Yes.
Yes, sir.
And what is the likelihood? If you see, it's from Poisson distribution, right?
Yes, sir.
Okay, so what would I write? First of all, tell me.
Yeah, likelihood is nothing but the product of
All,
probabilities of
yeah, basically,
which
yeah. So what we have to do? So posterior is proportional to
likelihood
likelihood times
prior.
prior, right? So
Yeah.
what is the PMF of Poisson distribution? E raised power minus lambda, lambda raised power x divided by x factorial, right? So this is something we have to do for 10 times, right? We have to multiply this 10 times or not?
Correct.
So this
Yes,
is
sir.
proportional to, it will be e raised power minus lambda, lambda raised power x1 divided by x1 factorial into e raised power minus lambda, lambda raised power x2 divided by x2 factorial up to e raised power minus lambda, lambda raised power x10 divided by x10 factorial. I'm not writing the values. I will write at the end. Okay.
Yeah.
So into what is the prior? Prior is this part.
Yeah.
Lambda is for 5 minus 1 e raised power minus lambda.
Yeah.
Okay. So this is the prior part. So let's ignore this constant because we are not going to use the equality sign. So I'm just ignoring this because x1 factorial, because these all are values, right? 2 factorial, 5 factorial will be some constant, right? So what else I can write? E raised power minus how many times? 10 lambda? 1, 2, 3. Yes or no?
Yes.
Yes, sir.
Are you getting my point?
Yes, sir.
Yes,
And
sir.
1 second. Why 10, sir? I see 3 lambdas.
no, it's a dot in till x10.
Oh, okay, yeah, sure.
Okay.
Yeah, sorry.
And then it will be lambda is for x1 plus x2 plus so on x10,
Yes, sir.
right? This, or should I write one step? Let me write one step. Okay. So it will be e raised power minus lambda up to minus lambda into lambda raised power x1 into lambda raised power x2 and so on lambda raised power x10. And this prior already we have lambda raised power 5 minus 1 into e raised power minus lambda. All right. Now it will be e raised power minus 10 lambda and lambda raised power summation of xi's, it will be till 10, right? And lambda raised power 5 minus 1 e raised power minus lambda. I'm dealing with minus 1 only. So it will be sorry, lambda raised power 5 plus summation of xi minus 1 e raised power minus 11 lambda. Yes or no? Yes, no.
Yes, sir.
Sir.
Getting my point, right? So if you see, this is again what kind of distribution? If you see the gamma
Gamma
distribution,
distribution.
gamma distribution is what? X raised power alpha minus 1, e raised power minus beta x, right?
Yes, sir.
So if you see, instead of x, what we have to do? We have lambda. Lambda is for alpha minus 1. So this will be your alpha, right? And this is
Yes, sir.
beta,
Beta.
right? So if I'm saying x follows gamma, alpha comma beta, then fx is proportional to x raised power alpha minus 1, e raised power minus beta x, right? Instead of x, we have lambda. So what will be the posterior distribution here? It will be gamma. Tell me the parameters. 5 plus
5 plus
5 plus
summation
summation
five,
xi,
comma
comma
11.
11.
11.
So
Yes, sir.
it will be gamma. What will the 5 plus summation xi? Basically, we have to add all these xi. So 2 plus 5, 7, and 11, 17, 18, 24, 27, 32, 34, 38 plus 38 plus 5, 43. No, no, I think any mistake is there. 7 for
Yes,
11.
sir. You counted 3 more. It will be 40, comma 11.
7 for 11, 6, 17, 18, 24, 27, 32, 34, yeah, 38. Huh? 7 for 11, 6, 17. No, sorry. 11, 6, 17, 18, 3, 21. Yeah,
18.
yeah. Sorry, I
Yes, sir.
counted 24. Yeah, correct, correct. So it will be 35, right? So 35 plus 5, which is 40,
40.
comma.
40, comma 11.
Is this clear?
Yes, sir.
Okay, and if you see the next question, what is the posterior mean? So posterior mean will be
40 by
alpha by beta. So 40
Yes.
divided by 11, whatever the values, right? So 40 by 11 will be how much?
3 point something. Closely to
Yeah,
3.6.
3.63. This 6 is coming, so which is 64, right? Till 2 decimal places. Is this clear?
Yes, sir.
So are you able to
Yes,
relate
sir.
Yes, sir.
how you can proceed? The smartest approach, whenever you are getting any constant, you can include in proportionality sign. Okay, let's do one more question, which is again similar to this. So I want you should try for this question, and answer is in front of you, but do not tell me blindly, or else you can tell me, I will solve. What should be, or you want to try? Then I can give you some time. Would you like to try?
Yes,
Yes.
sir.
Yes, sir.
Yeah, just please try and let me know. Okay, then this is the very last question. We can end after this.
Done, sir. Matched.
Yes, sir.
Okay, so how did you proceed? I mean, you did for 10 particularly, or one more thing you can do. I would suggest. I mean, it's up to you whether it's you're going with that. So basically, you can do in general first thing. In general means let me do it. Okay, everyone has done, right?
Yes, sir.
Okay, so if
Sir, I
X,
have a quick question I'd like to ask.
yeah.
Sir, can you scroll a little bit up?
Yeah, one second. So if x is follows gamma, alpha, comma, beta, then what will the fx? It will be x raised power alpha minus 1 and e raised power minus beta x, right? Proportional. I'm ignoring the constant. Yes. Yeah, please tell
Yes.
me.
Sir, the part where we have the
Yes.
x a little bit up, sir. Sir, sir, where you have x1 factorial and then x2 factorial up to
Yeah,
x10
this one.
factorial.
This one.
Yes, sir. Yes, sir. What do we do with that?
Yeah, actually it's a proportionality sign, right? We are not doing equal sign, right? Equality.
Okay.
So under proportionality, you can this constant you can basically ignore. You can say in simple terms.
Okay, I see, sir.
Yeah,
Thank
it's
you.
not equality sign. We are not taking all the terms, right? Similarly, here we are doing with the this PDF one. In general, PDF is fx. If it's gamma, so it will be beta raised power alpha divided by gamma of alpha and this term, right? Now we are ignoring the constant. That's why I'm writing fx is proportional to x raised power alpha minus 1 e raised power minus beta x. Okay.
Perfect, sir. Thank you.
Yeah. Now let's do in general. So here lambda is gamma 5 comma 1. Then what will be f of lambda? It will be lambda raised to alpha minus 1 e raised to minus beta lambda, because lambda we are treating as a random variable here. So if you see what is the posterior says, so the very basic thing we have seen, posterior is what is proportional to likelihood times my prior information, right? So what is the
Yes.
likelihood? Likelihood is here for Poisson distribution, right? So let's do in general, and then at the end we will do. So in general means what is the likelihood? E raised power minus lambda, lambda is for x1 divided by x1 factorial into e raised power minus lambda, lambda is for x2 divided by x2 factorial, and so on. E raised power minus lambda, lambda is for xn divided by xn factorial, right? Into what is the prior? Prior will be lambda raised power alpha minus 1 into e raised power minus beta lambda. Correct?
Yes, sir.
Now, what will be this part? If you see, it will be e raised power minus lambda into e raised power minus lambda up to e raised power minus lambda. Okay.
N times.
And 10 basically,
N
and
times.
lambda is for x1 plus x2 plus so on xn.
Yes.
Right? And in the denominator, it will be product of xi factorial.
Yes.
And it will be lambda raised for alpha minus 1 e raised power minus beta lambda. So since we are dealing with proportionality sign, so it will be so I can ignore this part. It will be e raised power minus n lambda and lambda raised power summation of xi, right, into lambda of lambda raised power alpha minus 1 into e raised power minus beta lambda. Would you agree with me?
Yes.
Now
Yes,
what
sir.
I can write is proportional to lambda times or lambda raised power alpha plus summation of xi minus 1 and e raised power minus n lambda minus beta lambda. So I can take this lambda as I mean basically minus lambda as a common, then it will be n plus beta lambda. So you can see this is again gamma, right? Lambda
Yes.
for alpha minus 1 e raised power minus beta lambda. The difference is instead of lambda and sorry alpha and beta, it's alpha plus summation of xi comma n plus beta. Correct?
Yes, sir.
So what you have to do basically you have to substitute alpha and summation of xi. So what is alpha here? Alpha here 5.
5.
Summation of xi is 7, 4, 11 and
28.
12, 6,
28.
28. So 28 plus 5. This will be 33.
Yes.
And this is 1 and 10. So this will be 9
11.
is 10 and this is 1. So this is 5. This is 28. So this will be gamma distribution 33 comma 11. And what will be the mean here?
3.
So you see mean is correct. So mean in case of gamma distribution, if x follows gamma alpha comma beta, then mean is alpha by beta. So posterior mean will be here 33 divided by 11, which is 3. So which is the answer? Is this clear?
Yes, sir.
Okay.
Yes.
Yeah, so it's clear, right? So week 9 and week 10 concepts are clear.
Yes,
Yes, sir. Clear.
Then I think we are basically done with week 9 and 10. So basically, all the very best to all of you for this your end term exam. So just
Thank you, sir.
thank
Sir, week 11 and 12.
Yeah, it will be there. Right?
Sir,
Yeah,
next revision session you are going to take?
most probably yes. So week 11 and 12, it will be. I think it's on Wednesday, right? Upcoming Wednesday,
Yes, sir.
18th December.
Sir, request to share the formula file which you have, sir, because I don't have that, sir.
Yeah,
You
I will
told-
share. Yeah, basically, I will share with the team. So I'm not sure about by today. Maybe tomorrow they will upload. Okay.
Sir,
You can share, sir, here itself. Also on
So I
the
think G chat is not. We can't paste. Yes, yeah, yeah. You saying something?
good evening, sir. Sir, I just want to ask you, sir. Sir, can you explain us some basic questions which are going to repeat or something else, sir? So, because I have not prepared well for the end term examination.
Basically, basic questions. I just.
Okay. Sir, actually, sir, some questions are going to be repeat. Sir, questions, type of questions. I'm not asking about question. So, type of questions which are going to be repeating end term examination. So, can you
Yeah,
tell
I
me?
think Vivansu, correct, right?
Yes,
Correct pronunciation. Yeah.
yes, sir.
Yeah, that's why I took the question from last term end term exam. So I can assure you, if you are able to solve this kind of questions, right? That's
Yes,
why I have
yes,
written here. It's a kind of very important, right? So this kind of similar questions you can find, not this question, right? Same concept.
yes, yes, sir.
Okay.
Sir, but
And, one more thing, yeah, in the same pattern you
yes,
can find, in this pattern you can find not this question, but you should know how to apply the concept only, right? So
yes,
that's why I took some examples and I solved this kind of questions is also important. So I would request to all of you, you can try this questions also. TA will take some PYQ sessions, just try to solve this question, this kind of questions also. This estimator and all, right? This estimator, the key thing you should know, if you are talking about bias is 0 or unbiased estimator, then you have to equate expectation of theta hat equal to theta. So this theta is the true value and this theta hat is the estimate, I mean the thing which you are going to basically estimator, function of sample values. Okay. The basic idea you have to keep in your mind. Others thing, if you don't spend or your time on memorizing, oh, what is the expectation of uniform, what is the variance of uniform or exponential. If it's in your mind, that's very good, because it will save your some minute, because in exam you have to scroll up, scroll down, right, to see the formula and something like that. If it's in your mind, that's very good. If it's not, don't worry, you can check the formula and you can proceed with the formula also, right? The thing is, you should know which concept you have to apply. Okay. Similarly, I mean, when I will take the revision session of week 11 and 12, I will explain you this kind of situations, right? When sigma square is known to you, then when you can go for jet test, then t test, when you can go for t test. I mean, various kind of situations we will see in week 11 and 12. In this, yeah.
what about week 1 to 8? Is there any session for week 1 to 8?
No. So week 1 to 8, we took already for quiz 1 and quiz 2. You can recheck that one. Okay.
Okay, sir.
Yeah. All right.
So, what type of question can be expected from week 5 to week 8, sir? Because
It's see, if you ask me, it seems easy to me, but under exam pressure sometimes.
I understand.
So under exam pressure you might fail, but I can assure you, if you are able to do the graded level questions, right, that is more than enough. Right? That won't create a big problem.
So like if we solve the PYQs of quiz 2, will it help?
Fine. Not little, it will help you a lot actually.
Okay, sir. Thank you, sir.
Okay. Okay. All right, then we can
Thank you,
wind
sir.
up. Right? So tomorrow's
Yes.
you have OPP, right? Then I can shift the session till from 6:30. 6:30 we can start because some of you have the OPP till 6, right? Then tomorrow session let's do from 6:30 onwards, right? I think it's about week 12. Then we can discuss week 12 concept. Okay.
Okay, sir.
Okay, sir.
Okay, sir.
Okay.
Thank
All
you,
right
sir.
then. Thank you.
Thank you, sir.
Hope
Thank
it
you,
was
sir.
helpful to all of you. Yeah. Good night. Good. Bye.
Good night, sir.
Yeah. Good night. Bye.